So we're going to look at engine size measurement right now. And you can see that the picture I have here says Hemi 5.7 liter. And the 5.7 liter stands for the number of liters that the engine has. Now, what does that mean? What does that look like? Well, I'm going to show you what that is, and I'm going to show you how to calculate it on an engine, and then you're going to go calculate it on an engine. So the first thing we need to do is get some terms straightened out. And so there on this first picture, you can see that we have this term right here. It says bore. That's the cylinder bore, or the diameter of the hole that the piston is fitting in. That's that full diameter, and that's the bore. Excellent. The next thing we'll talk about is the stroke. The stroke is the distance from the top of the piston when it's at the bottom of the stroke to the top of the piston when it's at the top of the stroke. So the stroke is when the piston goes from the bottom to the top, or from the top to the bottom, and that is always staying at the same length for that particular engine. And TDC stands for top dead center, and BDC stands for bottom dead center. So when we talk about top dead center and bottom dead center, stroke and bore, we know exactly what we're talking about. So let's move on to the next picture. And you can see that when the piston is at the very bottom, as this piston is right here, as compared to when the piston is at the very top over here, so this is at TDC here and BDC on this side, you can see that there's a certain volume of space in that area from when the piston is at the bottom to when it's at the top. That's the measurement of the displacement, how much volume that piston displaces when it goes from the bottom right to the top. So we're going to calculate that. So let's do that. Here's the formula, and you can see that I've got a picture down here on the right, and that picture is telling us that inside this cylinder there is a bore right here that is 3.917 inches and a stroke right over here which is 3.578 inches. So what we're going to do is we're going to put that into our formula here. D equals pi 3.14 times, now we're going to, instead of writing a half, we're going to go 0.5 times the bore, which is 3.917, and that's going to be squared, times the stroke, 3.578, times the number of cylinders, and in this case it's an 8-cylinder engine. Good, let's do that again. 3.14 times, now what will this be? Let's calculate that. We've got 0.5 times 3.917 equals 1.9585. 1.9585. That's squared times 3.578 times 8 equals 3.14 times, now what does that come out to? We're going to square that 1.9585, and that's going to give us 3.835. 3.83, if we round up, it's 3.836 times 3.578 times 8. So let's figure this out. 3.14 times 3.836 equals times 3.578 equals times 8 equals 344.7. So we're going to round it up to 345. 345 what? Well, we're in inches, so this comes out to cubic inches. So it's a 345 cubic inch displacement engine. And if we go back to our top picture here, that's exactly what 5.7 is, except 5.7 is in metric. So 5.7 liters equals 345 cubic inches. That's the cubic inch displacement. So what does this look like in the real world? Um, if you look under the hood of your car, if it's a small 4-cylinder car, right on the valve cover, it might say 2.5 liter engine. Well, that means that the displacement of all 4 cylinders is 2.5 liters. Or let's say you have an older truck and it's a 350 Chev half ton. That means the cubic inch displacement is 350. And in that case, they round it also to 5.7 liter engine. So anything in that general area equals a 5.7 liter engine. And so that's how we figure out the engine size measurement.